Okay, so remember sine at these values, sine is y, right? So we're looking at the y for each of these ordered pairs. So sine is going to be 0, 1, 0, negative 1, 0. Now, what do I do to sine to change it into cosecant? Reciprocate, right? So what we're going to do is we're going to reciprocate each of the sine values to change it into cosecant. So what is the reciprocal of 0? It's undefined. What's the reciprocal of 1? 1. What's the reciprocal of 0? What's the reciprocal of negative 1? Negative 1. And the reciprocal of 0? Undefined. So what's happening is every place that we have an undefined, we have something called an asymptote. And we talked about asymptotes for like a half a second at the beginning of the year. And kind of like a wall in the graph where two pieces, or it kind of divides the graph into two pieces, where it's not gonna, they're not gonna cross through, something like that. They're getting closer and closer. They're approaching that value, but it's not going to equal that value. So at 0 on my graph, I'm going to have an asymptote. So I'm going to go over to the graph and I'm going to draw x equals 0. And you can't really see it. I have a red line here. It's kind of hard to see though. Make it a little thicker. At x equals pi, that's my second asymptote. At x equals pi. And then at x equals 2 pi, I've got another asymptote. Now, what do we know about these graphs in all the way to the left, all the way to the right? What's happening to these kind of graphs? Like if I go this direction, what's always happening with the graphs? When we did sine and cosine. It goes on forever, but how am I able to go further? Why do I only need like 5 points and I can keep going? Why? Because there's a pattern. It repeats. It's periodic. It cycles around and around and around again. So because of that, I can graph a bunch more asymptotes now because they are how far apart? They're 2 units. What is that? Yeah, they're pi apart. Thank you. So on the graph, yeah, they're 2 units, but if we're talking number-wise, they're going to be pi apart. So that undefined is going to repeat. That undefined is going to repeat forever. So do you see you have to list all your asymptotes here? Yeah? You got to list all your asymptotes? Yeah? What did I just say about that? Can you take that out? Huh? I got to list all of them. Kind of. So what you're saying is, I'm not literally going to write, here's my first asymptote at x equals 0. Here's my second one at x equals pi. Here's my third one at x equals 2 pi. I also have one at x equals negative pi. And at x equals negative 2. Like, I'm not going to list all of the ridiculous, they go on forever. So what we're going to do is we're going to list all of them using a variable. So asymptotes would be that x equals, and then we're going to start with the lowest asymptote that's not negative. So I like to start with the lowest asymptote that is not negative, just to make this consistent, because I really can start with whatever asymptote I want, and if there's that many options, then we're all going to have different answers, and it's going to be a pain in the butt to see if we're all right. So I just suggest starting with the first asymptote that is not negative. So what asymptote is that? 0. And then for that asymptote, we're going to add on what value? Okay, but we're not just going to add 1 pi. I mean, sometimes we'll add 1 pi. Sometimes we'll add 2 pi's, because that'll give us to 2 pi. Or we could add 3 pi. Or we could add 4 pi. Or we could add negative 1 pi. Or negative 2 pi. Or negative 3 pi. What is in common with all of the numbers in front of the pi? Okay. Not whole numbers, because whole numbers don't include negatives. What's the word that includes the negatives and the positives? They're integers. Right. So what we're going to do is we're going to say that every, and I'm going to come up with a variable on the spot. Just kidding. This is what everybody uses. K pi. We're going to use K pi. We're going to say K is a variable. So that K can change, but K can't be any number. So now we're going to say where K is an integer. That's why that line was so long. So x equals 0 plus k pi, where k is an integer. That means k is any integer, and we can plug in any integer. It will be an asymptote. Now, I will not have an answer like this written as 0 plus k pi, because 0 I don't need. So I will simplify it and write it as x equals k pi. That there, so you knew where I got like that first value. Okay, almost done. Now we've got a couple other values to graph. We have pi over 2 is at 1. And we've got 3 pi over 2 is at negative 1. Now, with a different color, I am going to sketch in the sine function. Where's my yellow? I'm going to sketch in the sine function for you so you understand why the cosecant looks the way it is. Oh, here it is. So you guys should know what the sine function looks like because you've done it a lot from that big packet you just turned in. And this doesn't have any transformations on it. Oh, shoot, I missed one. Oh, no. I messed up. This side's good. Nah. Okay, don't look so much on the left side. All right, so what's happening is when we flipped the number 1, it was still 1. So this new point at 1, 1 is in common with the other one. And then same thing with the negative 1. We reciprocated that, and they're still the same. At pi over 6, now here. At pi over 6, what is the sign at pi over 6? 30. So what is the cosecant at pi over 6? Oh, wait, the sign is not 30. Did I just say 30? What's the sign? It's a half. I thought you were saying the right answer. You weren't, sorry. So when I reciprocate that, we get 2, and it goes up there. All right. At 5 pi over 6, it is also, the sign is also a half. And if I reciprocate 1/2, I get 2, so it goes all the way up there. This little section in between the asymptotes is not a parabola, but you'll think it looks parabolic in shape somewhat, but it's not a parabola because it gets closer and closer and closer to an asymptote. It doesn't infinitely go out. And then when we do the third and fourth quadrants between pi to 3 pi over 2 to 2 pi, and I'm thinking about the same thing, and I'm saying, well, at this 30-degree reference angle, it's negative 1/2, and so if I flip that, it's negative 2. Just kind of did the same thing I did there. It's going to look like a parabolic shape, kind of, not exactly parabolic, because it does have asymptotes, and it will never cross those, but going down. So you can see that that starts at the relative max and min values from our original sine graph. And then from there, you really don't need those extra points. I just wanted to show you a couple points in there. What you need to know is the basic general shape of this, it's not a parabola, the cosecant graph. So the yellow that I put in there is not part of your answer. If you like having the yellow there to help you, that's totally fine. But it's not part of your answer. So that's what cosecant looks like. Did anybody who took honors last year remember doing that? Did you guys do it last year? Or is this the first time you've seen it? Vaguely?
Yeah.
Okay. So it was so fast and not important at the time that...
Yeah, I think we went over it at some point.
Okay. The other classes did not do it, so I was just curious because I don't know what you guys all do. All right, so now we're going to do the exact same. So first, we're going to start with cosine to make secant. So cosine is the x values around the circle. So the x's are going to be 1, 0, -1, 0, 1. And when I flip those and reciprocate them, 1 undefined, -1 undefined, 1. So I like to do the asymptotes first. The asymptotes will be where x is pi over 2 because y is undefined. And where x is 3 pi over 2 because y is undefined. So you can see the asymptotes are in a different place than cosecant. Then we'll follow that pattern to put all our asymptotes in. And then I'm going to write the equations of the asymptotes. So I'm going to ask you, what is the first asymptote not negative? It's right here at pi over 2. So we'll say x equals, and we're going to start with pi over 2. How much each time? So from 2 to get to 3 pi over 2, those are 2 blocks. That's pi. That's the value of pi. So I'm going to say k pi. And then you have to define that k is an integer. So we're going to go ahead and graph 0, 1, pi, -1, 2 pi, 1. You guys remember cosine looks like that, and then it keeps going. The secant is a lot like the cosecant, where there's going to have that relative maximum right here for your secant. This is just going to go the opposite direction. So just like sine and cosine look a lot alike, cosecant and secant look a lot alike. One thing you'll notice is the two pieces are never going towards each other. They're away from each other. Because I don't want to have to find other values. I just want to use the values from the table, those five easy values. You just have to remember that they're always going away from each other. Okay? So now let's do that with transformation. Okay, so when I do this, I say this one's secant, or cosecant. Which is cosecant the reciprocal of? Sine. And when I'm doing this, I like to throw the sine values in there really, really small so I remember what they are. Sine values are 0, 1, 0, negative 1, 0. But then in my y value, I have to flip all of those. So we'll have undefined, 1, undefined, negative 1, undefined. All right, what's the 3 do? Vertical stretch. So that goes on the vertical side. We're going to multiply everything by 3. So if I take an asymptote, here's an asymptote, and I stretch it vertically, I pull it up and down vertically, what happens to that asymptote? It's still there. It didn't move anywhere. It's still there. So this is going to still be undefined. If I take an asymptote, and I'm sorry, we have a plus 2. Where does that plus 2 go? Is that vertical side or horizontal side? Why do you know it's vertical? Because it's not in parentheses, so that's a translate up 2. So if I take an asymptote, here's my asymptote, and I move it up 2, it's still there. Because the asymptote's like an infinitely long line of where it's not passing. So that does not affect the asymptote. Nothing on the vertical side will affect the asymptote. What would get my asymptote to change? Yeah. Horizontal stretch or shrink will take asymptotes and move them apart or move them closer together, and a translation will move them left or right. So it's the x side that affects the. All right, so we have our asymptotes at 0, pi, 2 pi, and then pattern. So let's go down and fill out the blank that says asymptotes while let's freshen our mind right now. Asymptotes. X equals the smallest one that's not negative. Where is our first asymptote that's not negative? It's at 0. I'm not going to write it because it's at 0, but I'm doing 0 plus. And then what am I adding each time to get the next? Pi. So I'll say k pi. And then I need to add where k is an integer. All right, pi over 2, 3, and 3 pi over 2, negative 3. Uh-huh. Oh, I forgot to, my bad. I just forgot to fill that out. So 5, and then what, negative 1? Sorry. Pi over 2, 5. And pi over negative 1. And then follow the pattern. 1 is up, 1 is down. If that one's up, the next one's down. And then up. And then down. Okay, when we talk about the period for sine or cosine is 2 pi. All we did was reciprocate the numbers, so the period is still 2 pi, unless we have some sort of stretch or shrink that's going to change it. So did we have a horizontal stretch or shrink for this one? No, so our period is still 2 pi. From start to finish, one full cycle, one up and one down is 2 pi long. Phase shift, did we translate to the left or right? So we write none. Don't leave it blank. Tell me you know there isn't one. Vertical shift, did we translate it up or down? We did. We went up 2. Okay, so the domain is everything that x can be. So all the way to the left, all the way to the right. Is it every single number? It is not. What numbers is it not? The asymptotes, right. It's not the asymptotes. So what we're going to say, you can't do this in interval notation because you'd have to write every single little piece with a union, and there's infinitely many, so we don't do this in interval notation. So what we're going to do is we're going to look at the asymptotes, and we're going to say that x cannot equal k pi where k is an integer. So it's all of the asymptotes is what x cannot equal. Other than that, x is all real numbers, except for those spots. So whatever your asymptotes are, that's going to be your domain, except for domain is not equal to. And then the range is how far down to how far up. Do we go all the way down? Do we go all the way up? Well, yes and no. We go all the way down, we go all the way up, but we don't go through every single number. We skip something. So we're going to have 2 separate pieces for the range. The first piece is going to start at negative infinity and stop at negative 1. So we'll say parenthesis, negative infinity, comma, negative 1, bracket, union. Then we're going to start again at what y value? 5, bracket, positive infinity. So this is like opposite of what it would have been. If I had drawn in my sine graph, my sine graph would have looked something like that. Sorry. My sine graph would have looked something like this. So my sine graph, the range would have been between negative 1 and 5. Here it's going away from them, so we have 2 separate pieces. Okay? Oh, it's so easy, isn't it? Let's try secant. Let's try secant. So secant, it's which one flipped? Cosine. So I like to remind myself this is cosine. I would like to remind myself what the values are. 1, 0, negative 1, 0, 1. And then I flip them. 1, undefined, 1, undefined, 1. I'm going to look at my transformations. I have a negative and a 2 in front. What's the negative going to do? What's the negative going to do? Reflect in the x-axis. And the 2 is going to be a vertical stretch. So we can take both of those at the same time and multiply our y's by negative 2. And then what's this minus pi going to do? It's going to go right pi units. So we'll add pi to our x side. So on our y side, we're multiplying. When you multiply undefined, it doesn't change anything. It's still undefined. On our x side, we're adding 0 to pi, so pi. Then we've got 3 pi over 2. And then 2 pi, what is this? 5 pi over 2, and then 3 pi. Okay. So now I'm going to look for my asymptotes. And the asymptotes are the ones that are undefined, but we're going to look at the x, the like new x's. So my first asymptote down here is going to be at 3 pi over 2. And then at 5 pi over 2. And we know that these are always going to be the same space apart, so I can continue the pattern and more asymptotes. There'll be 1 at pi over 2, and negative pi over 2. So where do my asymptotes begin? X equals, what's the smallest asymptote that is not negative? Pi over 2. And we get that by looking at the graph. Plus, how far apart are they? So k pi, where k is an integer. At pi, the value is -2. At 2 pi, it's +2. At 3 pi, it's -2. So then I can follow the pattern. One goes up, one goes down. Question? Anybody have a question? We will start at 2 pi and we'll use a horizontal stretch or shrink. Did we have one question?
Was there a reflection in that?
Yeah, the reflection came from me multiplying by -2. So where it was at 1, I would have just moved it up to 2 or to.
So the graph's not good.
Well, it's hard to tell. The graph would have been here. I think it looks the same. Do you know what I'm saying?
Well, it's a reflection that also has the pi, which is shifted over.
Right. Oh, you're saying it looks a lot like the original. Is that what you're saying? Yeah. So here's my original. You see how these look the same? Is this what you're saying, Marco? Yeah. You see? You guys see how they look the same? It's because I did a reflection and I translated it over. So I reflected this one, but then I moved it this way. Or did I move it this way? I moved it to the right. So it ends up being in the exact same place. So it does look the exact same, but I did have reflected. Yeah. Okay, so my period would be 2 pi unless I have a horizontal stretch or shrink, which I did not. So 2 pi. My phase shift is to the right, pi. My vertical shift, we didn't have one. The domain is going to be all real numbers except all those asymptotes. So we say x does not equal pi over 2 plus k pi, where k is an integer. And then range, it's going to start at -infinity. We're going to go all the way up to -2, put a bracket. Union, we're going to start it, and we're going to go up to +infinity and put a parenthesis. Because we have 2 pieces, it skips over this. When are you guys leaving? Oh, 40. Okay. I was thinking it was 30, so then I was like, oh. All right, the last one, I'm going to get you started on, but then I want you to actually try it on your own. Look at the equation, and right away I see secant. So secant is which one? Cosine. So I'll think about my cosine values, and then I'll flip them. Sometimes people forget. They like go in a different order, and then they forget, and then they just use the original values. They forget to flip them. Yes.
For clarification, you have to factor that one, right?
That is a very good question. That's why I wanted to get you started on it. Do we have to factor this one? Yes, we do, because both the stretch and the translation are in the parentheses. They're both horizontal, so we are going to have to factor this. So we're going to have y equals secant 1/2 parenthesis. We're going to take out that 1/2 and get x plus 2 pi. So you can think about that backwards. You can say half times what gives me pi. Half of what is pi? Well, half of 2 pi. Or you can divide by a half, which is the same thing as multiplying by 2. So you're transformations, you're going to use this equation. So I'm going to pause this, and I want you guys to try it on your own. Answers up at the end. And then I'm going to hand out your worksheet since a couple of you are leaving for that field trip. Make sure you hand out the worksheet. Okay, so as soon as I start to fill out the table for this, half is horizontal. So that means it has to reciprocate, and we have to multiply my b values by 2. And then the plus 2 pi is also horizontal, so we have to minus 2 pi to the x values. So 0, pi, 2 pi, 3 pi, 4 pi. And then subtract 2 pi. So negative 2 pi, negative pi, 0, pi, and then 2 pi. So I have my first asymptote at negative pi. And then my next asymptote is at pi. And these asymptotes are 4 blocks apart. So when I go to follow the pattern, 4 units over here. When I go to write the equation of the asymptotes, what is my first asymptote that is not negative? Start at pi. Say x equals pi. And then I'm going to add on how far apart they are. How far apart are they? They're 2 pi apart. There's a few ways you could get that. You could look at the table and look and see how far apart is it from pi to negative 2 pi, or to negative pi. Those are pi apart. You could look at the picture and count the blocks. So they're 2 k pi, where k is an integer. 2 k pi. All right, and then graphing negative 2 pi is 1. 0 is negative 1. And then 2 pi is 1. And these will, again, they're going to approach these asymptotes. Look like that. Was there a horizontal stretch or shrink? Yes, so normally the period is 2 pi, but whatever we did to the x's, we also do the period, so I'm going to multiply it by 2. Our period is now 4 pi. There was a phase shift. We went to the left, 2 pi. Was there a vertical shift? No. The domain, how do I find the domain? How do I find the domain? Cameron, how do I find the domain? Same as asymptotes except what? Does not equal, right. And then the range is going to be 2 pieces. We're going to start at negative infinity, and we're going to go up to negative 1 with a bracket, union, start at positive 1 with a bracket, go to infinity. Where is a good place you could go to check answers, just in case you're not sure if you're doing it right? Oh yeah, well my answer key will be posted. Before that, Desmo, so you can go type it in. Just type in the equation. It will graph these for you, and it's very user friendly. And now that you've learned these, if you wanted to add any of these to your roller coaster project, you can. It's not a requirement. The requirement is sine and cosine, but you could add these if you want that particular shape. However, you know you couldn't add both pieces because it has to be continuous, and how are you going to do that on a roller coaster? Well, you'd have to be clever in which way you would add it. Like, I could imagine myself taking like this U shape, maybe just using this part of it, and then connects over here, like two pieces. So that, I mean, you would not be able to use through the asymptote area on your project. Okay, but I just want to let you know, like, as we're learning new ones, you can use any of those. You can also use any of the ones that we've covered in class so far on the project. And I'm pretty sure I told you before, but if you go above and beyond the requirements, I will feel like I have to give you extra credit. So, you know, if you